All right, so I'm working hard to make a tree diagram here for you guys. We are still in 5-1. I know it's taken a while, but that's all right. That's how lecture goes. All right, so a tree diagram is not an essential thing. It's an old school technique that they did back in the day, and we continue to do to this day to organize things. It's very much like a flow chart. So you want to construct the sample space for a woman who has 2 children. So let me go to my little drawing here. All right, so this will be the first child. So you say, look, at the beginning, over here at the apex, you say, she's sitting there, she gets pregnant. Then it could go either way. It could be boy or it could be girl. Okay, so it goes through. Now, it could be a boy, and then from there, that's the first kid. And then from there, you could have another kid, and that gives you your second one. Hold on, drawing my pictures here. Oops, move over. There we go. Okay, then the second kid could be a boy, again, or could be a girl, right? Okay, so what are the options so far? So far we have boy, boy. That's an option. Then we have boy, girl is another option. And by the way, they abbreviate that as all the time, BG, BB. Okay. Now I'm going to pause and I'm going to make the other wing. Hold on one sec. All right, there I'm back. Okay, so here's the first kid. So when you have your first kid, you have a boy or a girl. Then you could have had a boy, and then there's your second kid, or you could have had a girl, and there's your second kid. So it's a way of organizing what's happening. So the 4 options for your sample space are BB, BG, GB, and GG. That is your sample space. So, and we've made a tree diagram to show it. Okay, so then what is the probability that they are both boys? Well, let's look here. BB was this option up here out of 1, 2, 3, 4 possibilities. So the chances they're both boys is 1 out of 4, which is 0.25 or 25%. What is the probability, or why is the probability found in the above considered classical? Well, I didn't go poll women, right, to get these numbers. I didn't check, right? I didn't poll women to check the numbers, or it doesn't have to be women. I didn't go to hospitals and actually count the number and proportion of male and female babies. I just assumed that they're both equally likely. i.e. 50-50. And of course, I didn't even get into children that are born transgendered or anything like that. I didn't even mess with that because that just makes things more complicated. So probability-wise. So I didn't bother with all that. I just said, oh, I can figure this all out without having to go get data, right? In other words, no data was collected in any way, shape, or form to figure out these probabilities. The diagram or the probabilities. That is the heart of classical probability. Right? Classical probability is the kind where you can figure it out just by looking at it. Speaking of heart of classical probabilities, so the people that invented this stuff, they really invented it for the deck of cards. And if nothing else from this class, you definitely should learn how to play cards, insofar as you should learn what the suits are and such. So if you go play some solitaire, say it's for class, that's fine. Now, what's the chances of an ace? So in a regular deck of cards, there's 52 cards. The aces are these 4. So the chances of an ace are 4 out of 52. I'm just going to leave it as a fraction, but of course you could find the decimal with Excel. All right, what's the probability of a black card? Well, there's half of them, right? Because half of the cards are black, which would be 50% or 0.5. What's the probability of a 9 of diamonds? Well, there's only 1 9 of diamonds in the whole thing. So that's 1 out of 52. And last but not least, what's the probability of a red spade? Well, you can't get a red spade. Spades are black, so that's 0. And if aces are low, what's the probability of kings are higher? That's 1.